We move to the part 2, the writing part of the EOT. The 16th question is problems on optimization. They're all real world problems. I would highly encourage all of you to read the problem and understand what it means. I will read it out now. A three-sided fence is to be built next to a straight section of river which forms the fourth side of a rectangular region. The enclosed area is equal to 1800 feet square. Find the minimum perimeter and the dimension of corresponding enclosure. Remember, this is writing part. You need to write everything in detail. So first thing what I would suggest is draw a simple diagram to understand better. Now they have told the fourth side is there is a river which is a straight river. Imagine that's a river. You're building a fence and one side of it is the river itself. So you will just build it on three sides. Okay, that's not straight, but just imagine this is a straight line, straight line, straight line. This is a fence you're building. Now here, how I've drawn is a vertical river, and this is the horizontal length x, x, and y. Now imagine if you have drawn a river like this and you drawn the fence like this. That is also fine. It's just that you will have y, y, x. Both is fine. You will get the final answer to be the same. Now let's try solving it up. What is given? Area is given. Whatever is given needs to be written first. What is the formula of area? Area will be equal to length into breadth, and since over here x and y is taken, the two dimensions will be x times y. Here x, y. Doesn't matter we don't have the fourth side, the area will be the same. See, this is the area, right? The enclosed area, it will be the same, x times y. Now we know area is 1800, so we have x times y. Why do we need this is, we will write this area in terms of a single variable. In the sense y, we will leave it over here, take x to the other side. So it will be 1008 divided by x is equal to y. Now we got the area. From the area equation, we can write y is equal to 1800x. Why did we do this? Because they have asked us to find the minimum perimeter. Now what is the formula of perimeter? Perimeter is 2 times length plus 2 times breadth. But here it's just a three-sided fence, right? So how many x's are there? It is 2x plus y, or you can take it as 2y plus x. It's fine, you will get the same answer. And what do? Here you can't differentiate. See, you need to find the minimum. Minimum or maximum means you need to derive this and find the critical numbers. But here, since you have x and y, it would be implicit derivation and it will be very complicated. You won't be able to solve it. So what we do is we write this y in terms of x, right? We will substitute over here now. We will get p is equal to 2x plus y would be 1800 by x. Even over here you could do the same thing, it's fine. It's just that the when you solve it, the answers will be the same, just the methods will be different. You can try this by yourselves. Now here what happens is only one to do, not both. I'm considering this one and I'm solving it over here. Now what happens over here is you need to derive this p dash. It's all with respect to x, so it will be just 2. And now what is the differentiation of 1 by x? 1 by x can be written as x to the power minus 1, and it would be minus 1 times x to the power minus 2, because we have to do power minus 1, power rule over here. And this can be rearranged and written x by 2 squared. Why? Because this goes down, it will be positive power. Now instead of doing this all the time, you can easily remember the formula for 1 by x derivative is minus 1 by x squared. Here 2 minus this plus becomes minus 1800 constant divided by x squared. This is the derivation we get. This is 2. Okay, 2. And now what do we need? We need to find the critical numbers. How do we find critical numbers? Is equating this is equal to 0. And now we get 2 minus 1800 by x squared. You can just take this to the other side and solve it up. It will be 1800 by x squared equals 2. Swap these. It'll be 1800 by 2 equals x squared. 1800 by 2 is 900. You need to take square root on both the sides. Square root over here will be 330. X will be plus or minus 30. So this is the answer for x. Now here there is an important thing which you need to know. X cannot be negative number. Why? Because we are dealing with the real world problems. Here there is an interval x must be greater than 0. Okay, and over here look, it's divided by x. You cannot have x equals 0 as well. I can't write less than or equal to y. It would be undefined here. That wouldn't make sense. So x must be greater than 0. This is a condition. Just by looking at this problem, you should understand. And since it's a width, you're considering x to be equal to positive 30. So that is the x value we got. And there are no endpoints over here. X can be greater than 0 until any point. So that's fine because we have no clue what is the x, right? So now we need to find the minimum perimeter. In fact, in almost all the problems, we can just take this as the minimum perimeter value. So x must be 30 and then you can find y. But before we do that, we have to just double check whether this is true. What do I mean is double check whether this is the minimum perimeter. So there are various ways. You can do double derivative test, or I will just stick to single derivative with the number line method. If you do this, it's more than enough to check that that's the minimum perimeter. I just erase this part now. Now, over here we have this p dash we just now derived. Now we need to do a number line. Just draw a straight line and write the x value. Now since it's not plus or minus, we have concluded that it must be positive number, so it can be only x is equal to 30. That's the critical number. And you can just choose any value less than this, but avoid 0 because that will be undefined. So I'll take 1, any number less than 30. You can take 29 as well, it's fine. And take any value more than 30. I'll just take 31. I'll take a easier number. 50 is easy to calculate, or 100, so you can take anything, so it's up to you. And now what you need to do is substitute these values in the derived equation. See, this is for p dash of x. Okay, this number line, the first derivative test. Here, substitute this number over here and check whether you're getting a positive or negative value. So when you substitute 1 back in over here, what happens is you will have 2 minus 1800. It will be a negative number, minus sign, so it's decreasing. Now, whenever in the first derivative you get negative over here in this number line, this means it's decreasing. And what about if you substitute 100? If you substitute 100, it will be 100 squared is 10,000. Then it will be 10,000. 1,800, it's less, so it will be obviously less than 1. So it will be a very small number basically, and it will be positive over here, okay? Because it will be 2 minus a very, very small number is a positive number itself. You can just put it in the calculator and check it. Don't do like, if you're getting confused, just put in the calculator, you will get the answer. So here we can see it's a minimum point. So x is equal to 30 is minimum. Okay, this is the way to prove it. And now once you have done this, we can conclude that x would be the minimum most. If you use x dimension as 30, that would be giving you the minimum perimeter. So what do you want to find? Y as well, right? So what is y? Y is equal to 1800 by x, which means it's 1800 by 30. This 1 times, this is 6 times, and 0 remains. It will be 60. This is the y value. So we can conclude saying for minimum perimeter, we need to have x, that is the length, as 30 feet, I believe, yes, feet, and y has to be 60 feet. This would be the answer. Now I have not written the steps. This would be the first step, and the second step would be the derivative part with the perimeter. This number line would be the step 3. Okay, there are only 3 steps. Please try to draw a rough figure. It will be much better to understand and solve it up. You can see here, these are the dimensions, 30 by 60. The worked out solution is also available. You can go through this. And over here we have again the same type of problem. The only difference over here is they have told the perimeter which is available. Now, I have done the entire lesson explanation, and the similar problem is done in that, I believe, where the perimeter is given and you have to maximize area. Try it by yourselves and then refer to the solutions over here. And now, this one, I will solve it over here. The thing is, if you look at this, a two-pen coral is to be built. What exactly is two-pen coral? It's something like this, a place where you can, um, protect the sheeps or cows or something like that, where it's two joined enclosed places. Okay, it's basically like one rectangle and one more rectangle joined together, and they are same, equal. Okay, this is a two-pen coral. Now this is to be built. The outline of the coral forms two identical adjoining rectangles. They are mentioned. It is not always the same sign, but same size, but they have clearly mentioned it's two identical rectangles. If there is 120 feet of fencing available, that means perimeter is told. Perimeter is how much? 120 feet. What dimensions of the coral will maximize the area? Needs to be maximized. In this case, what you need to do is basically write the perimeter formula first. Perimeter is, now this is important. Is it 2 times x plus y? It is not this formula because it's a two-pen coral, right? So it'll be basically similar to this. I just draw like this, and over here middle, it's another line. So now if I consider the horizontal distance as x, x and x, this vertical distance will be y, this entire length, and this will be entire length y. Now the perimeter over here would be 1, 2, 3x plus 2y. This is the perimeter. And what is the perimeter given? It's 120 is equal to 3x plus 2y. And now you can easily solve it up. But first thing, you need to rearrange and write y in terms of x. That means take 3x to the other side. It will be 120 minus 3x plus is equal to, 2y equals 2y, and divide both the sides by 2. You will have 60. 120 by 2 is 60 minus 3 by 2x equals y. So now we found out y. This is the y value. Now we need to maximize area, isn't it? So this is the step 1. Now step 2 would be writing the area formula, that is x and y. That's it. Because x into y would be the enclosed area. Over here, area would be x times, what is y? Y is 60 minus 3 by 2x. That's it. That's the. Now, what you do is multiply this x inside. Don't derive it directly. It will be a product rule. It's a bit complicated. I mean, you can go ahead, but you will just save time if you multiply this inside. It will be 60x minus 3 by 2x squared. And over here, when you derive this with respect to x, obviously, it'll be 60 minus, this 2 comes down, it'll be, this cancels, it'll be 3 times 2 by 2, right? This reduces, so this cancels. So you will have 60 minus 3x. This is the derived equation. Now, to find the critical number, you need to equate this to 0 and now solve it up. Take this 3x to the other side. It will be 3x is equal to 60. X will be equal to 30 by 3 will be 20. So x is 20. Now let us do the step 3 to check whether this is the maximum enclosed area. We need to maximize the area. So let's do the number line. Here it is 20. Oh, by the way, x must be greater than 0 no matter what. Otherwise, this would not make sense because it must be a positive number. There is no n interval, so we'll just take this as derived one, this one. Okay, now whatever the value you get, you put in the derived equation. So all you're going to do over here is take a value. I will just take 0 because it's not undefined anyway, right? Yeah, it's not undefined anyway. So I will just take 0, less than 20, and more than 20, I'll just take it as 50. It'll be easier. And now what you do is substitute the 0 in the derived equation. If you substitute over here 0, it's going to be positive. Why? This term becomes 0, right? Over here is much easier. This term becomes 0, you will have only positive value. It's increasing here. What about 50? 50 times 3 is negative 150, but minus sign makes it minus 150 plus 60, which is basically negative 90. So it's minus. We are not interested in the value, we are just interested in the sign. And this is the thing. X equals 20 is maximum value. And now you have the x value already, substitute and find the y value. Y is equal to 60 minus 3 by 2x. That means it's 60 minus 3 by 2 into 20. 1 time 10 times. It will be 60 minus 3 times 10 is 30. It's 30. Y is 30. So you will have maximum area when the dimensions are 20, it's feet, 20 feet by, sorry, x is 20. It's 20 by 30 feet. Okay, 20 feet by 30 feet. So that's the answer. So this is how we solve this problem over here. And let's just look into the solutions as well. Um, yeah, everything is right. But look over here, I had taken 3x. Okay, I had taken x, x, x. I taken like this. But over here in the solution, it's same. The answers are same, no problem. It's 20 by 30. But what they have considered in the figure is like this. So what happens is they have taken x, this entire thing as x, and bottom as x. So you have 2x plus y, y, and y, 3y. Even if you do like this, you will get the same answer, no problem. It's just that, this equations will be a little bit different, but it's all right. You can follow whichever you're convenient, whichever is easy for you. And now we have the box problem. No, sorry, it's not the box problem. I thought it was a box problem. This is about a showroom. Let's read this problem. A showroom for a department store is to be rectangular with walls on three sides. Okay, the three sides only has walls. And then 6 feet door openings on two facing sides and 10 feet door opening on the remaining wall. The showroom is to have 800 feet square of floor space. What dimension will minimize the length of the wall used? It's just a little bit of difference and then it's all the same. Now, if you're finding this is all too long, you can, continue solving all these videos by yourselves. But since I'm finding these are all, different type, I'm going to solve it anyways. But you can just skip forward or you can just skip the video if you've understood thoroughly. Try to solve these by yourselves and just go ahead. Now, how do you solve this is, first let's draw a simple diagram here. So I will, it's a open, see, a showroom, right? There's an opening. It's kind of like this, okay? Just imagine this is the opening. Obviously, it'll be much bigger, but mine, okay, just understand these are the walls. Now, in these walls, if you consider this to be X, okay, and this is also X, then this is Y. What has happened? There is a 6 feet door opening, so you need to remove that. So it'll be X minus 6 feet over here. Same thing over here, x minus 6 feet, and over here it will be y minus 10 feet. They have clearly mentioned it. 3 walls only, and these are the door opening, okay, on the remaining of wall. So, yeah. What dimensions must minimize the length of wall used? We must minimize the length of wall being used. The area is given. The floor space means all this region, right? That's basically the area. So, how do we solve it is, first of all, we need, it's not the perimeter exactly, these sides, right? Because over here, we are removing the, the sum part. Let us write it in terms of length will be equal to y, there's only one y plus 2x. I hope this is clear. But this is the actual one if it was just walls without the doors, okay? It's like the perimeter only. You can consider this to be perimeter, it's fine. But here, what is the problem? There is some changes in this x and y. So L is equal to y becomes minus 10. And what about x plus 2 times x minus 6? Now we need to solve for length. Because here we can see here the area is given, right? So let's write the area formula first. A is equal to 800. So what is area? Is x times y. But here, do we have x and y? No, we don't have x and y, right? What do we have? We have basically x minus 6. No, what you can do is let's consider x and y itself, okay? Because what we will, it's easier to keep it as x, y, x only now. And I'll just rearrange this. 800 is equal to x, y. And what is y? Y will be 800 divided by x. Now, this is just a simple rearrangement. Now, y is found out. Now, let's find the length, the perimeter, or I'll just write it as length. What is the length? There is 2x, x plus x. I'll write it 2x plus y. There is y1 length, then the open side, right? Here now, what I'll do is, I will write x minus 6. Why? See, for area, you can't write x minus 6 because area is this entire length, even including the door, the door space as well, because it's a floor area. But for the length, it's not like that. For length, x is basically x minus 6 because you have to remove the door area, door, whichever the space for the door, right? Because you're just doing the wall without the door, right? So that's why we use x as x minus 6. So x minus 6 plus y will be y minus 10. Now you basically multiply this 2 inside. It will be 2x minus 12 plus y minus 10. And now here, this is L. Now just try to rearrange. Oh, before we can simplify this. What you can do is take this to the other side. It'll be 2x. No, don't take it to the other side. Sorry. Solve it. Plus y minus 22. Now substitute the y value. Y is plus 800 divided by x minus 22. This is the length which we got. It's all with respect to x now. Now derive it with respect to x itself. You will have 2 minus 800 by x squared. If you're thinking why, we just did it some time ago in the video. That's why. And this will become 0, so don't write it. Now this is the derived equation. Now we have got, this is just to write y in terms of x. Now we have got the derived one. This is the length. Now they have asked to minimize the length right over here. So let us just check whether it's minimum or no. Oh, sorry, before that, you need to put this as 0 and solve it. Okay. So what happens is here L dash derived one will be equal to 0, that is equal to 2 minus 800 by x squared. Take this to the other side, it will be here. What happens is it will be 800 by x squared equals 2. Now change it over here, it will be 800 by 2 equals x squared, cancels, it'll be 400. What is the square root of 400? It's 20. So x is plus or minus 20. So this is the answer. These are the critical values. But we know x cannot be negative. X must be greater than 0. So x will be positive 20. Remember, x cannot be 0 because it will be undefined over there. It should be a positive number or greater than 0. So here it is 20, take a value less than 20, that can be 1, and over here it can be anything like 50. And now this is L dash of x. Do the same first derivative test and check. Over here is the derived. Where is the derived? Over here, this one. Substitute 1, it will be 2 minus 800, it's a negative. And when you put 50, 50 squared is a huge number. It will be less than 1 for sure. So it will be 2 minus a small number is positive. So it will be minus is down and up. So x equals 20 will be the minimum value. And yes, this is proven. It's the minimum length now, whatever you find out. And what is the y value? Over here, y equals 800 divided by x is 20, right? Now solve this, it will be 40. So y equals 40. When you have the dimensions of x equals 20 and y equals 40, you will have the minimum length for the wall. So this is how we solve it out. You can see here it's 20 feet and 40 feet. So this is how we solve this problem. And now we have a couple more problems. It's all proving show. So I will just explain these over here itself. Now show that the rectangle of maximum area for a given perimeter P is always a square. Now this is again a simple problem. Let me just solve it up. Let me write it and solve it up. Because over here there is no area, no perimeter. This is a different type. So what you need to do? See, first let's write the area formula and the perimeter formula. A is equal to xy. Perimeter is 2x plus 2y. We can't write anything in terms of y. We need to look here. They have told maximize area, maximum area. So this needs to be derived. Leave this. Now rearrange this in terms of y. So what do we do is take this 2x to the other side, be p minus 2x equals 2y. And see, it's just like how we solved previous problems, but it's just that they have told maximize area where perimeter is p. That's it. P is the perimeter. They have not given a value. There's no constant value. Imagine this is a constant. That's it. And now it will be p by 2. Divide both the sides by 2. It will be p by 2 minus x is equal to y. Now substitute this y over here. A equals x into p by 2 minus x. And now multiply this x inside. It will be p by 2x minus x squared. Now derive the area. We need to find this maximum area. So it will be p by 2 minus 2x. So I hope this much is clear. It's very basic till over here. Now, what do we need to do is find the critical number. We need to put the area derived is equal to 0 and solve for x value. So take this to the other side. It will be 2x is equal to p by 2. 2 to the other side. In the denominator, it will be x is equal to p by 4. So the critical number over here is p by 4. Now what you need to do is, here we don't have any way denominator as x, right? So x must be greater than 0 for sure, because we don't have in the denominator. I'll take, now to prove it, let's do the number line. Sorry, that's a crooked line. It's slanting down, but anyways, x is p by 4. Any value less than p by 4. You can take it as p by 8. It's fine because it's less than p by 4. You can take 0 because it's not undefined anywhere, right? I'll take 0. What is value greater than p by 4? P by 2 is greater. I'll just take, wait, 1 second. Yeah, p by 2 is possible, but I will take p by p itself. Okay, you can take p by 2, p by p, 3p by 2 or anything like that. Greater than p by 4. And what is this area? So what you do is look at this number and see what has happened. Where is the derived equation? This one. Substitute over here. When x is 0, what is the value over here? X is 0. This is gone. You will have p by 2. We have considered p as a constant value. It's a positive number, right? So it's going to be positive over here. Okay. And then what if this is p? So let me solve this. P by 2 minus 2 times p. It will be p half minus 2. What is half minus 2? It's 3 by 2. It's 1.5, right? 1.5 p. 3 by 2 p. Now this over here, sorry, negative. I forgot. Minus 2 plus half is negative 1.5, isn't it? You can just do 1 by 2 minus 2. That is negative 1.5. But we have p in both sides, so we write p over here. Okay, you can write p outside. So it's minus 1.5p. So it's minus here. This is plus minus. So what happens? It increases, decreases. So it's maximum area, right? So at p by 4, we get maximum area. So well and good. We got x must be p by 4. Now what is the y value? Substitute back over here. Where is y? This one. Y is equal to p by 2 minus x is equal to y, isn't it? So now substitute it back over here. What happens? P by 2 minus p by 4 is equal to, I don't know why I wrote it again. Anyways, so p by 2 minus p by 4 is how much? Again p by 4. Here you can see x is p by 4, y is p by 4. So whenever you have to maximize the area for a given perimeter, you get the dimensions equal. So it's basically the same dimensions, as length and width is same. So it is always a square. What is square? X and y is equal, right? In square, we got x and y equal. So hence we can conclude it's a square. So these are the steps, okay? See, follow the steps what I've written initially, step 1, step 2, step 3. I'm now writing it all of a sudden. I'm thinking that you understood the concept. Now we can easily solve them up. That's why I'm writing it directly. You can see the solution is also about that. It's basically you'll get the dimensions p by 4 and p by 4. That's why it's a square. Now over here, again, the same concept, minimum perimeter. It's just that we have to find the area in terms of y and then derive perimeter. Please do this by yourselves. It's the same concept. It's just the other way around. Try it by yourselves and then check the answer. Over here, all the explanation is there anyways. It's again a straightforward problem. Please check it later. Over here now we have the box problem, folding. Let's do this one. A box with no top is to be built by taking 6 inches by 10 inches sheet of cardboard, cutting x inches squares out of each corner, folding it up the sides. See what happens is you're cutting a square. Let me just draw a square over here, and you're cutting a square at each corner and then folding this up, this side up over here, up over here, up over here, up over here, and this is how you form this box. We need to find the x value that will basically minimize the volume of the box. Here all you need to do is the volume formula. This is easier. Why? Because we are not having two formulas. Say the first formula, then we need to solve it again. No, it's just one formula over here, so it's much easier. Now what do we do is, let's write this length. Since it's a little bigger, I'll take this as 10. And over here, x initially it was like this cardboard, right? Okay, this is a very bad cardboard, but a square of x, see, this is also not even, but it's all x, x, x that's been removed. So if this originally length was 10, 2x is removed. It will be minus 2x. This length will be 10 minus 2x. Okay, so what we do is write this dimensions as 10 minus 2x because 2x's are removed, and here also it will be 6 minus 2x. Now the volume is length into width into height or thickness, so volume will be length, I'll take it as 10 minus 2x into width is 6 minus 2x, and lastly height is x. That's it, that's the thickness, right? Now let's solve it. You can do x multiplied over here and then multiply, or I'll do like this. First the FOIL method. These two terms, it will be 10 times 6 is 60 minus 20x. Then this term over here will be minus 12x minus and minus will be plus 4x squared multiplied by x. Over here you can simplify. Look, it will be 60 minus 20 minus 12 will be minus 32x plus 4x squared. All things multiplied with x. This is x. So now multiply the x inside. It will be 60x minus 32x squared plus 4x cubed. This is how we get. This is the volume with respect to x. Now, how do we find critical numbers? Very simple. Derive this. So when we derive it, we'll get 60 minus this x square, right? 2 comes down. It will be 32 times 2. It will be 64x plus 3 times 4 is 12x squared. This is the answer. Now you just have to equate this is equal to 0, and I'll write the highest degree first. 12x squared minus 64x plus 60. Now, how can you find the x values? This is a quadratic equation. Use your calculator mode phi 3. Let's click on mode phi and look over here. Quadratic is 3. And put the first coefficient before x squared, it's 12, and then we have minus 64, and lastly we have 60, and the answer is 4.12, and we have got 1.21. So let me just write it. X is equal to 1.21 and 4.12. Now which do we select? There is an important step. Now this can be considered as step 1. Okay. Till over here, the derivation can be considered as step 2. Then there is an interval. So what you can do is, after the step 1 over here, you can directly do this interval as step 2. but now I'll write it as step 3 because I'm doing it now. So what does this mean? What intervals? So we know this is all real numbers, right? So we cannot have anything less than 0. So this dimension x must be greater than or equal to 0. This 6 minus 2x also must be greater than or equal to 0, and 10 minus 2x also must be greater than or equal to 0. This is basically common sense because we know x value must be a positive number. It's a real object. It must be more than 0. So this is what we are saying. So fine, x must be greater than 0 is the lower limit. Now let's solve this one. This is already done. What about this one when we solve? It'll be this one. Okay, I'll be solving it here. 6, I will take 2x to the other side, will be greater than or equal to positive 2x. Let me divide both the sides by 2. It will be 3 is greater than or equal to x. And now I'll write x first. It will be less than or equal to 3. 3 is greater, so the greater symbol must point at 3. So x is less than or equal to 3. What about this? So I will write this over here. 10 is greater than or equal to 2x. I'll swap this entirely first itself. 2x will be less than or equal to 10. Okay, because 2x is less, right? I bring it over here and 10 to the other side. And now divide both the sides by 2. You will have 2 is less than or equal to 5. So here we have got two conditions. One is x must be greater than 0. That's fine. It's open intervals, sorry, closed intervals, 0. But what about the other two sides over here, 5 and 3? What about these? You need to take the lower value. Why? Because if you take less than equal to 5, you can consider 5, 4, 3, 2, 1. But what if you consider 4? Let's put over here x as 4. What happens? It'll be 6 minus 2 times 4, which will give you 6 minus 8 minus 2. This dimension is minus 2, which is wrong. So you cannot consider this. Though it will satisfy this line, this dimension, it won't satisfy all. So this one just greater than or equal to 0. But over here, we have less than or equal to 3. So our upper limit will be 3. So this is 0 to 3. Now we have this as the limits. So we can eliminate this critical number 4.12. It's not within this range. So a critical number will be 1.21. And also the end points over here of the limit, the closed interval, will always be included as critical numbers. So now we will see this, the number line method. We will start with 0, 1.21 and 3 and take some test values. Here I will take a test value of -1. Here I'll take it as 1. Here 1.5, and over here I'll take it as 4 or 5. I'll take. Now substitute these in derived equation. We have done this, right, just a while ago. Same thing. Now you substitute over here and see how it is moving. Okay, let me use I'll just use the calculator over here. I'll tell you an easy method when there are many critical numbers, right, many test values, how you can do this. So in your calculator, type this equation as it is. Say 60 minus 64 alpha x plus 12 alpha x squared. Write that as it is. Now I've written y over here, sorry for that. It is alpha x. Now what you do is just calc at this value -1. What is the answer? Positive. Here it's positive. Now again calc at 1. Again I got positive. So both are positive. What about this? Calc at 1.5. It is negative. So I will just write over here. We got positive, positive. This was negative. Positive, positive, negative. And let's do the last one. Calc at 5, or you can even do 4. It's again positive. So here it is again positive. Now what do you understand from this? Here you understand it's increasing. This is the maximum. See, this one is maximum and this 3 is minimum. Sorry, not max, minimum. Minimum over here. So 1.21 was a critical number. If the x value is equal to 1.21, you will maximize the volume. This is what? Derivative of volume. So volume will be maximized when x is 1.21. The minimum will be at 3. So what do we need to do? Maximize the volume. So take the dimension of x as 1.21, and then you will be able to maximize the volume. That's the answer. So from this number line, you can consider it. So you need to do the test because it's a very rare situation, but generally it doesn't happen. But these endpoints also can be a maximum point. So better do the number line and check it for sure. So that's the answer. We got how much? 1.21. That is basically this. Let's just check in the calculator. What is this value? I have substituted this entire exact value over here. That is 1.21. That's what we also got. Now, sometimes your options will be like this, and you got decimal. Don't worry, just solve these options, all the four options, and check which is the correct answer. We had got 1.21. Yes, this is the thing. So x should be max. X should be 1.21 to be maximum. That's how we do it. Now, this is again the same problem. We just now solved it, right? It's just that over here it's 12 inches by 16 inches, no top. Please try to solve it by yourselves. Here also you have to maximize the volume, and then you can just do what we just now did. Solve it, do the number line, and find the critical exact value where you get maximum. Here is the worked out solution as well. And this is the last problem here. A box with no top is built by taking a 6 by 6 piece of cardboard, okay, cutting x inches squares out of each corner and folding up the sides. It's the same thing what we did. Okay, the 4x inches squares are then taped together to form a second box with no top or bottom. Okay, this is interesting. Find the value of x that maximizes the sum of the volumes of the box. Okay. See, you need to do the same method, but over here there is an extra part as well. We need to add this x also volume. And then we need to repeat it again for 4-inch by 6-inch piece of cardboard. Okay. So first we need to do this. Okay, I will do one of this, okay, and this is the same thing, repeat. If you have understood the previous problems thoroughly, you can attempt this by yourselves. It is just that there are two volumes. But anyways, now I'll solve this up. Here first let's write the volume formula. V is length, width and height. The same concept. Now I'm not going to draw I'll just draw it. Here we know it'll be taken out and be folded. It's 6 and 6. Minus 2x, and the height will be x. You need to substitute it over here. Length is 6 minus 2x, and the width is also 6 minus 2x, and over here multiply by the height x. Now first thing, this is the first box, okay, this box. Now I'll consider this as V1. It's much better. No, this is volume in general. Now what I'm writing over here is basically V1, okay, for this box. Now let me multiply this. 6 times 6 is 36 minus 12x plus 4x squared times x. And then what happens is it'll be 36x. This will be minus 12 will be minus 24 x, and multiply this x will be x squared plus 4x squared. And what next? Something I've missed out. Okay, over here there'll be x into x is x cube. Okay, so this is basically the volume of the first box. Now what about the second volume, the second box? It is all dimensions of x, right? The top and bottom is okay, not there, fine. It's x, x, x. So what is it? It's a square. Now how do you find the volume of a square? It's just x cubed. Why? Because it's the same dimension, x times, okay, so now thickness, height, everything is same. So basically the volume is x cubed. Here they have told, find the value that maximizes sum of volumes. So what we do is V equals V1 plus V2. So what happens here? I'll rearrange this right properly. 4x cube is there first, minus 24x squared plus 36x plus x cube. 4 plus 1 will be 5x cube minus 24x squared plus 36x. That's the thing. Now we need to derive this. That's V of x only. Now derivation v dash of x will be equal to, derive this, 3 comes down, it will be 15x squared minus 24 into 2 is 48x plus 36. Now make this equal to 0 and put it in the calculator and solve it up. Before that, now here we need to find the interval, right? But remember, from one box, we are doing one more box. So obviously the first one will be greater than 0. Here it is open intervals. Why? Because you can't just consider one dimension. Let's see the maximum value over here. It'll be 6 minus 2x. You can't write greater than equal to 0. I'll tell you in a minute. Let's solve this. It'll be 6 is greater than 2x. It'll be 3 is greater than x, or x is less than 3. So the limits are 0 to 3. But it's closed intervals. Why? Because you have included the volume of another thing as well, right? So what basically you can say is the critical numbers will matter a lot. This just must be greater than 0. It's just positive numbers over here. So even if you leave this, even if you remove this, it's fine. Why? Because all you need is positive numbers in this case. Okay, it should just be greater than 0. Now restricting, yes, obviously we can restrict it less than 3 because it can never be more than 3. No matter what, these critical numbers must be less than 3. But we can't consider this endpoints also as the volume. We can't consider the endpoints. Why? Because if you consider the endpoints, it doesn't make sense. This can't be as long as the endpoint. Okay, if you practically think of it. So only because we are adding the two volumes over here, we are not going to include, it's not a closed interval, it'll be open interval. And this is just for understanding. It's mainly x is greater than 0. And it should be any number less than 3. So now we need our calculators to solve this critical numbers. I've substituted these values here. It is 15 minus 48 and 36. The critical numbers are 2 and 6 by 5 is about 1.2. So let me write the critical numbers over here. X is equal to 1.2 and 2. Now here, since we have two critical numbers within the range, we need to consider both. Now you can do the number line, but what if the critical numbers both are increasing? So what we can do is, because see, it's a polynomial. Anyways, so what we can do over here is the easier method is just directly putting this equation into this given volume equation and finding which is giving you maximum value. Now we see I was doing the first number line, right? The first derivative test by number line. Try to stick to that itself because we have done it many times, so stick to that. But in this case, because we have two critical numbers, we need to substitute this in the volume equation, find which is giving you a greater volume, and that would be the answer. Let us do that now. All I did is I put this volume, sum of the two volumes, right? This equation, and now I will calculate it at say 1.2. What is the answer here? At 1.2, I'm getting 7.28, but check the volume 2 also. Calculate at 2, I'm getting 16. So which is the maximum volume? Because we are supposed to find the maximum volume, right? It is 1.2. So when x is 1.2, you will get maximum volume. So you can see over here, all that we did, maximizing at 1.2. Now for the next question B, you have to do the same thing, but just that we had done this, right? Over here, can you see this? Here it will be 1 will be the same, 6 minus 2x. 1 more will be 4 minus 2x. And what will be this end limit? Here we would have 4 minus 2x must be greater than 0. It's again open limit itself, and it will be 4 is greater than 2x, and 2 will be greater than x. So x must be less than 2. The limits will be 0, 2. That's the difference. And over here it will be 4. That would be the change, and then everything is same. Obviously the critical numbers will also change because the values will be different. You can see over here it's written out over here. So this would be the answer. It will be 0.911. So that is how we basically solve this real world problems on optimization. That's all the problems. I would highly recommend you to solve each of the problems by yourselves and practice. So see you in the next video. If you have any doubts or questions, please post them in the comments and I'll try to get back to you very soon.